In our last video on operational amplifiers, we took a look at a summing amplifier where we added 5 volts and 2.5 volts to get our 7.5 volts out. Now, we took 5 volts and we put it through a 10K resistor and a 2.5 volts through another 10K, and those were tied together and tied to terminal 3 here. Then we said that on terminal 3 we'd get 3.75 volts out due to KCL, Kirchhoff's current law. And in order to get 3.75 volts on terminal 2, then the output would have to be 7.5 volts, twice that, because this comes back through a voltage divider. So we get our sum here. We add those two together and it gets 7.5 volts. Now, how do we get this 3.75 volts on terminal 3 there? So here's Kirchhoff's current law here. Now, in his law, it says that the algebraic sum of all currents entering and exiting a node must equal 0, okay? So here it is here. We've got our negatives of the two power supplies, and they're tied together. And then we have our 5 volts coming into one resistor here. In this example, I use 1K, but you can use 10K. And 2.5 volts going into this resistor here. And we want to find the voltage at N right here, okay? So we're going to use Kirchhoff's current law. We're going to say that the voltage, the current between the two, if we add those together, it's got to equal 0, okay? Now, sometimes it's not very intuitive. It's like superposition, it's not intuitive, but we use it and it works. So we'll assume that these two are going to be 0, okay? So in order to find the current there, we know our resistance and we know the voltage going in. We don't know this value over here though. So we take our 5 volts here and our 2.5 volts here, and we know our resistance, so it's going to be 1,000 in this case. Now, the denominator is the same, so we can just join them together and make it 1,000 here. And so then, to simplify it, we can just add these two together and to 7.5 and minus our 2n. We have 2n's there, minus 2n, right? And that's got to be equal to 0 still. Now, to get rid of the 1,000 here, we multiply each side by 1,000. So we have 7.5 minus 2n is equal to 0 times 1,000. So that's going to be 0. Now, we want to subtract. We want to get something to the other side here. So we're going to subtract 7.5 from both sides. So we get rid of that, and we get a minus 7.5 over on this side, okay? Now, we want to divide both sides by minus 2 to get rid of this 2 here. So we divide that by 2, it leaves our n here. Minus 2 goes into minus 7.5, 3.75 times. So that's our 3.75 volts that we get right here. And if we put that back into this formula here on n here, we have our 5 minus 3.75, which is 1.25, and we add that to our 2.5 minus 3.75 volts. That's going to be a minus 1.25, so that's going to be equal to 0, and so whatever we divide into that is going to be 0. So that's how we do the math for it, but we're going to see if it actually works. So I've got 2 resistors here. These happen to be 10K resistors. And I'm going to turn the power on here, and we'll take a look at this. Okay. So, can you see that? So, on this point here, I have, well, 2.43. Should be 2.5, pretty close. And what do we have over here? We have a little higher on this side, 5.05. Now, in the center, let's see what we get in the center of this thing. 3.74, okay? So, these are, that's how it works out. So it's right in the center. We get our 3.74 volts, should be 3.75, but we're not, these aren't the same here. So that's how it works. And that's it. That's Kirchhoff's current law. Thank you.